So in this video, I'll be talking about functions. But before I do that, please do subscribe for more videos. There are two common forms of notation used when talking about functions. We have this common one as f of x, for example, is equal to x squared plus 4. And then we have f of x, and then we map it like this. It is equal to x squared plus 4. This one right here, the second one right here, is interpreted as function f such that x is mapped onto x squared plus 4. These are the two common function notations that are used. I'm going to do a few examples so that we get to understand how functions are worked out. If h of x is equal to x squared plus 1 and g of x is equal to 10x plus 1, and we're asked to find part A, h of 2, h negative 3, h 0. And then part B, we are looking for g2, and then we have 10, and lastly we have g negative 3. We are going to go over this step by step. Part A, we have the function h of x is equal to x squared plus 1. And then we're told that our x value is going to be 2. So what this means is whenever you see anywhere in the expression where there is x, you substitute that x value for 2. So this is what we're going to do. 2 squared plus 1. And that is 4 plus 1, which is equal to 5. We have h negative 3. So we're going to say negative 3 squared plus 1. That's negative 3 times negative 3. That gives us a positive 9 plus 1. That is equal to 10. And lastly, we have h and we have 0. So we say 0 squared plus 1. And that is 0 plus 1. That gives us 1. Part B, we have g of x is equal to 10x plus 1. The first one is g of 2. So we're replacing x with 2. So that gives us 10 multiplied by 2 plus 1. That's 2 times 10, 20 plus 1. That is 21. Then we have g of 10. That means 10 multiplied by 10 plus 1. That's 10 times 10, 100 plus 1. That's 101. And lastly, we have g and negative 3. So that's 10 multiplied by negative 3 plus 1. That's minus 30 plus 1. That gives us minus 29. Now let's look at two more examples. F of x is equal to 1 minus 2x. Then h of x is equal to 12 over x. In part A, we're going to find x if f of x is equal to 1. We are simply replacing this f of x with 1. So we'll say 1 is equal to 1 minus 2x. Now we want to find the value of x. We'll take 2x to the other side so that it becomes a positive value. 2x is equal to, if we take 1 to the other side, we get 1 minus 1, that is 0. So x is equal to 0. Part B, we have x. We're finding x if h of x is equal to 1. So this is the same as saying 1 is equal to 12 over x. And if we cross multiply, we get x is equal to 12. Functions can be illustrated as flow diagrams. And that is what we are going to be looking at next. Part A says f of x is equal to x squared plus 4. And what we're going to do is to come up with a flow diagram for this function. So we always start with x and then can use this notation. We say x and you square it for it to become x squared, and then you add 4 for it to become x squared plus 4. So this is like breaking down each component for you to then come up with the whole function. So you always start with x, and for you to get x squared, we squared the x, hence this is the answer that you get. So when you put your arrow like this, whatever you put on top is the outcome of whatever command you would have said right here. In this example, we started off with x, and then we had a command here which was to square the x for us to get x squared. And then we had another command which was to add 4, and we found the final function as x squared plus 4. Let's do another example whereby we have f of x is equal to 2x plus 5 squared. Remember, you always start with x. So you look at the question, what did we do to the x value? We multiplied it by 2. So you say multiply by 2 to get 2x. And then what did we do next? We added 5. So you say add 5. And when you add 5, you get 2x plus 5. And then we squared the whole expression here. So you tell us that you will square it. And once you square it, you get 2x plus 5 squared. And that is the same as what we have right here. You can do it in a shorter way, whereby you start off by saying x, and instead of writing it in full as multiplied by 2, you just say times 2. And then you get your 2x. Instead of writing add 5, you say plus 5. And again, you get your 2x plus 5. And then where you cannot put a symbol, or where you cannot put it in a short manner, you can simply write it, right? So here we have square, and we have the final expression as 2x plus 5 squared, like this. So we're going to look at another example, which is part C. And we have f of x is equal to 4 multiplying 3x plus 1 squared plus 5. So this is a bit long, hence I'm going to use the shorter notation. Remember, we always start with x, right? So let me use a different color. We started off with x, and we multiplied it by 3, and we got 3x. And then we added 1, so that is plus 1, and we get a result of 3x plus 1. And then we are going to square it, right? And once we have squared it, we are going to get a result of 3x plus 1 in bracket squared. And after squaring it, what did we do? We multiplied it by 4 right here, which is outside the bracket. So you say times 4, and the result is 4 outside the bracket, then 3x plus 1. And after that, plus 1 squared. And then after that, we added this 5. So you say plus 5. And you finally get your full or your whole expression as 4, 3x plus 1 squared plus 5. Instead of writing it in full, you can easily do it in this way, whereby you're just stating what is being done, where you can possibly do so. So this is how you get to do flow diagrams. It's simply stating everything that is being done to get the final function starting from x. See you guys in the next video.